Hiya, so today we're going to have a look at some exam questions all about finding the equation of a tangent or a normal to a curve. So let's have a look at this question here. So we're told that the curve has equation y equals x squared plus 2x and it passes through the origin. And we're asked to find an equation for the normal to that curve at the origin. So the origin means it's the point 0, 0. And the equation of a straight line, which the normal is a straight line, we know that we have the equation y minus y1 equals mx minus x1. And here in this case, we're being asked to find the normal of the curve at the origin. So that means that they've given us essentially what our coordinates for x1 and y1 are. It's going to correspond to that 0, 0 of the origin. So we'd substitute those in. And then for m, that is the next thing that we need, all right? So m is the gradient. And we need to ask ourselves, how are we going to get the gradient of this curve? And in a question like this, when we're given a curve, we can get by differentiating the gradient of the tangent. So once we know the gradient of the tangent, so that relates to the gradient of the line which just glances the curve, the normal is perpendicular to that. And so that means we use our fact that the gradient of a perpendicular line is equal to the negative reciprocal of the other line. So in this case, the gradient of the normal is going to be equal to minus 1 over the gradient of the tangent. So if we differentiate this, dy dx, timesing by the power and subtracting 1, x squared goes to 2x, and the plus 2x, but here goes just to 2. And we're looking at the point where x equals 0. So when x equals 0, dy dx, if we substitute that in, just leaves us with 2. Now that, like we said, is for the tangent. So the gradient of the normal is going to equal the negative reciprocal of that. So it'd be minus 1 over 2. So now we know the gradient that we need to use in this question because we're being asked to find the equation of the normal. And so that will give us y minus y1, which we said is 0, equals m, which in this case is the gradient of the normal, minus a half, and then x minus 0 again, because again, we're looking at the curve and the gradient and the normal equation when we're at the origin. So this simplifies down to just leave us with y equals minus a half x. Okay, so in part B, we're asked to find the coordinates of the point where the normal to the curve at O intersects the curve again. So whenever we're talking about points of intersection, I always know that the chances are this is going to be a simultaneous equation question. So there's certain phrases in A-level maths which just mean something else, okay? So it's all about just getting clever to that and understanding that that happens. So in this case here, I know that y equals x squared plus 2x, and I also know that y equals minus a half x from what I just got in part A. So if I put those together then, and say, instead of y, I write minus a half x, and then it's equal to x squared plus 2x. I can now rearrange this to solve it. So getting all the x's onto one side, I get x squared plus 5 over 2x equals 0, okay, because I've just added a half x to both sides. So now I can factorise this, and I get x brackets x plus 5 over 2 equals 0. So if I was to solve this now, I can see that I have x equals 0, which is what the origin was, and I also have x equals minus 5 over 2. So the x coordinate in this case is going to be x equals minus 5 over 2. But see, the question wanted the coordinates, okay? Didn't specify just the x. So that means that we need to find out what y is as well now. So we could either substitute it into y equals x squared plus 2x, or just y equals minus a half x. I know which one I think is easier. I would substitute it into y equals minus a half x. And in that case, I get y equals minus a half times minus 5 over 2, which is y equals plus 5 over 4. So there you go. So in this case here, the coordinates of the point where the normal to the curve intersects the curve again would be minus 5 over 2, 5 over 4. Perfect. So let's try another question then. So here we're given a curve with equation y equals root 8x passes through the point A with x coordinate 2. And we're asked to find an equation for the tangent to the curve at A. So a really, really important thing to notice here is that y is not just root 8x, it's root 8x. The x is also under that square root. So that means that we've actually got y equals root 8 and then root x, which is the same as root 8x to the half. So in this question, we're asked to find the equation for the tangent to the curve at A. So that will be y minus y1 equals mx minus x1, because the tangent, just like a normal, is just a straight line. So we want to use the equation of a straight line. So we know from the question what the x coordinate is. We know that that is 2. So that's one thing that we know. But we don't currently yet know what the y coordinate is when x1 is 2. And we don't know what the gradient is either. So we need to work those out. So first thing that I would probably do is work out what my y is. So I know that y is equal to root 8x. So that means that's root 8 times 2, which is root 16, which is just 4. Okay, so there I would say that my y1 is therefore equal to 4. So I know now x1 is 2, y1 is 4. And now we need to find the gradient. So because we have a curve here, not a straight line, a curve, if we want to find the gradient of a curve, we differentiate it. So here we're differentiating y equals root 8x to the half. So to differentiate a polynomial like this, remember we need to multiply through by the power. So that's going to be a half times root 8, and then we take one away from the power. So we've got a half times root 8, x to the minus a half. Now we can simplify this a bit. Root 8 simplifies down to give us 2 root 2. The reason for that, just to check in, is that that's the same as root 4 root 2, which is 2 root 2. But you know what? If you typed in root 8 into your calculator, it should just give you 2 root 2 if you're feeling short of time or unconfident. And then x to the minus a half. So you can see that the half and the 2 cancel out, and then we get left with just root 2 x to the minus a half, which again you can even rewrite as root 2 over root x, or x to the half on the bottom there. And the reason why that's particularly important is because, of course, we now know that dy dx is equal to root 2 over root x, but we don't just want it at any point, we want it when x is equal to 2, as it said in the question. So if we substitute that in now, then we get that dy dx is actually equal to root 2 over root 2, which is just 1, okay? So now that we know that dy dx is just 1, we can put it back into our equation of a straight line. So we get that y minus y1, which we said is 4, equals m, which is just 1, x minus 2, which will simplify out just to give us y minus 4 equals x minus 2, which you can finish off with y equals x plus 2. So that there is going to be your final answer, and that is the equation for the tangent to the curve at point A. So I hope that made sense. I hope you can remember that the key things here that we need to know are the gradient of a tangent of a curve is just equal to dy dx. We just need to differentiate. Then we need to know that the gradient of a normal, because it's perpendicular to a tangent, is just equal to the negative reciprocal of the tangent. And then finally, we just need to know, because the tangent and the normal are simply straight lines, we just need to know the general equation of a straight line, that y minus y1 equals mx minus x1. And really that is all of the facts that you need to know to do those questions. Well, good work, and I look forward to seeing you on the next one. Make sure you subscribe. Bye!